Hello there, welcome to Chemistry First Quarter Test Review. We're going to cover Chapter 1 today. So what you'll need is your calculator. You will need your question sheet right there. And that's going to be about it for today's lecture. Before we get started, just want to, if this video ends up helping you, then please consider buying me a coffee. There will be a link in the description box so you can scan this QR code. All right. So number 1 here says convert 14.781 centiliters we want to put that over 1, and we are asked to convert it to kiloliters. So to go from centiliters to kiloliters, so we'd have centiliters, but then we need to convert to the base unit, liters, and then kiloliters. So this would be a 3-step process. So first let's convert to liters. We're going to put liters on top, centiliters on the bottom, because you put the one on the bottom that you're trying to cancel out. Which one is bigger, a liter or a centiliter? Well, a liter's bigger, so we put the 1 there. How many centiliters are in a liter? It's 100. So now you've converted to liters, we will convert to kiloliters. So we put kiloliters on top, that's what we're trying to go to. Put liters on the bottom, what we want to cancel out. Kiloliter is bigger than a liter, so we put the 1 by the bigger one. And then there are 1,000 liters in a kiloliter. So this is going to end up being a pretty small number here. So we've got, start with 14.781. We're going to divide that by 100. And then we're going to divide that number again, since they're on bottom. If they're on bottom, you divide by 1,000. All right, and that gives you 1.4781. E to the minus 4, you can just write that as times 10. Remember, E and times 10 are the same thing. To the minus 4, and then don't forget your unit. It's minus 1 on the test if you forget your unit. So 1.4781 times 10 to the minus 4. Okay, so that would be, if you're doing that in... maybe your calculator, if your calculator is not in scientific notation, would be 0.0001471. That's the same thing. All right, so let's take a look at number 2. Number 2 says convert 27.68 inches cubed to milliliters. Well, on this one, you have to remember that a milliliter is the same thing as a cubic centimeter. So if we can convert to cubic centimeters, then we know we have milliliters. Also, we know that 1 inch is equal to 2.54 centimeters. You do have to memorize that one for the test. Okay, so let's start. Always start with what you've been given. That's 27.68 cubic inches. I want to put that over 1. Now I want to convert that to cubic centimeters. So we're going to put centimeters on top. Now we don't cube it yet. We're going to do that at the end. Inches on the bottom. All right, what's bigger, an inch or a centimeter? Well, an inch is bigger. An inch is about 2.5 times bigger than a centimeter. So put the 1 there. 2.54 on top, 2.54 centimeters to an inch, and then we have to cube the whole thing. That'll get us centimeters cubed, but it also gives us inches cubed on the bottom, which will cancel out the inches cubed on top over here. So how do we put that in our calculator? Okay, you do 27.68 times, and then what we have on top is 2.54, and we're going to raise that to the 3rd power. So that's 453.54 0.59, and it didn't ask you to put this in correct number of significant figures, so we'll just round it to 2 decimal places. We'll get to the significant figures in a minute. 453.59 centimeters cubed, which is also equal to a milliliter. So boom, there you go. My experience is with conversions, when someone has to raise to a power, so we're doing area or volume and you have to raise to a power, that some students do struggle with that. So there are example problems in blue in your book if you need to go over a couple of those again. All right, and then our next one is convert 1.72 millimeters to kilometers. Well, we're going from millimeters. We've got to go across the base unit meters and then to kilometers. So we've got 1.72 millimeters. Put that over 1. Then we're going to go to meters. Put millimeters on the bottom so it'll cancel. A meter is bigger than a millimeter, so we put the 1 by that. And there are 1,000 millimeters in a meter. So you do have to remember that. 1,000 for milli, 100 for centi, etc. And then we want to go to kilometers or kilometers, however you want to pronounce it. We are canceling out meters, so let's put that on the bottom. Kilometer is much bigger than a meter, 1,000 times bigger. There are 1,000 meters in a kilometer. So we're going to go 1.72, divide that by 1,000. I like to hit enter in between, and then divide that by 1,000 again. So that'd be 1.72 times 10 to the minus 6. And don't forget the unit, we are in kilometers, all right? Because meters canceled, millimeters canceled. All right, so not many kilometers there. But hey, 1.72 millimeters is not very big. Okay, number 4 says convert 0.00004722 to scientific notation. All right, 0.000. How many zeros? 1, 2, 3, 4, 5. 4722 to scientific notation. Okay, so this is we're going to go to the right, and this is a number that's less than 1, so we're going to have a negative. We're going to raise it to a negative power. We're going to go to the right until we get just past the first non-zero. So we're going 1, 2, 3, 4, 5, 6. 6 places. So that's going to be 4.722 times 10, and then it's a little number, so it's 10 to the minus 6. All right, fantastic. Okay, number 5, convert, oh, look at that big number. 6, 010, are zeros to scientific notation. Okay, let's write all this down. Got 6, 0, 1, 0, and then we've got 9 zeros. Doink, 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 doink. So we are going to count the number of places starting at the right. Now this is going to have a positive, not a negative, but a positive exponent. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we stop right before that first digit. Okay, so we went 12 spots, so that's going to be 6.01 times 10 to the 12th. All right, so don't do it as 601 times 10 to the 10th. That's technically correct, but the way we want you to do it is stop when you get to that very front number there. Okay. All right, 5 down, 6 problems to go. All right, number 6. So we got how many significant figures are in 5.001000? Well, remember, significant figures really about the zeros. So we know the 5 and the 1 are significant. So the question is, what about all those zeros? Well, we have a 0 to the right of the decimal and at the end of the number. That counts. And then we have a bank of zeros in between two significant figures. So those two count. And then these two zeros are between the 5 and the 1, which are significant. So that's 1, 2, 3, 4, 5, 6, 7. So all 7 are significant. Okay, how about the next one? How many are in point? So number 7, we have point 1, 2, 3, 4, 5, and 4,800. Okay, we know the 4 and the 8. Those two are easy. We have a 0 to the right of the decimal and at the end of the number, so that counts. And then we have a 0 in between two red check marks, in between two significant digits. But all of these leading zeros are not significant. They don't meet the rule. So this answer is 4. All right, moving along. So number 8 says multiply 2.846 times 10 to the 15th. We're going to multiply that by 1.7 times 10 to the minus 11. And then we're going to round that to the appropriate number of significant digits. Okay, so let me remind you how to deal with these big numbers in the calculator. So we're going to use this double E button. That's the blue double E above the comma there. So we have 2.846. I'm going to hit second function double E. So you just get an E. And then to the 15th times 1.7 second function double E to the negative 11. Okay, so we get 48,302. Now, we could do that as scientific notation. It didn't give it in scientific notation, so that's okay. We can get the answer. Now, this isn't rounded properly. I'm just going to write it down, 48382. Now, how many significant figures do we have here in this number? We have 1, 2, 3, 4. How many do we have right here? So you don't count the 10 to the 15th or the 10 to the negative 11. We have 1, 2. So we must round to the lower of the 2. So that'd be 2 significant figures. So if you were going to round 48,382 down to 2 significant figures, you're going to round that down to 48,000. All right, fantastic. Okay, let's do number 9. Number 9 says we want to add 15.721. We're going to add that to 27.64. So we have a different rule on rounding. So let's go ahead and just put that in our calculator. 15.721 plus 27.64. Okay, that's 43.361. Now don't circle that. you round to the number that has the least precision. So this number is 2 decimal places. Okay, so we could just put 2 decimal, I guess. This number is 3 decimal places. So we're going to have to round this number to 2. You round it to the least precise. So that would be 43.36. Boom. All right, look at us go. Now what I would suggest for this test is, depending on, how much time you have to study, I would just rework all the extra practice problems from the 4 chapters and the little bit from chapter 5. That's a great way to study. Plus, you're going over this. All right, number 10. So we've got 2 density problems here, and you need to memorize that density is mass over volume. So number 10 says, what is the mass of 472 liters of silver, and the density is 10.5 grams per cubic centimeter. Remember, a cubic centimeter is the same as a milliliter, so the density is 10.5 grams per milliliter. Now, we were given volume in liters. We need to get that into milliliters before we do any calculation. So we've got 472 liters. We're going to put that over 1. Convert that to milliliters. Cancel liters by putting it on the bottom. Liter is bigger, and we've got 1,000. So that's going to be 472,000 milliliters. Okay, so now the question is, what is the mass? Well, rearranging this equation, remember you got to memorize this, rearranging that equation, if you multiply both sides by volume, you would have mass is equal to density times volume. So we know density, it's 10.5 grams per milliliter. We know now that the volume, we converted it, is 472,000 milliliters. The milliliters will cancel. That milliliters on top, that's on bottom, and you'll get the answer in grams. So let's go ahead. And we've got 10.5 times 472,000. That's 4,956,000 grams. Now, are we rounded properly? We have 3 significant figures here, 3 here. All right, so in order to round this properly, we're going to have to round to 3 significant figures, right? So here we actually have 4 significant figures. So if you want to round that properly, you'd have to round it to 4,960,000 grams. So that is the rounded answer. I don't know if your teacher on the test will require this type of problem to be rounded correctly, but that would be the correct way to round it. So we'll just go ahead and do it that way. Your teacher might accept this answer. All right, and finally, number 11, we have what is the volume of 0.12 centigrams of copper if the density is 8.92 grams per milliliter. All right, we know that density is mass over volume. We want to know what is the volume. I'm going to go ahead and solve for volume. Remember, if you're solving for the one on bottom, you switch with the one out front. So volume is mass over density. We know that we have a volume of 0.12 centigrams. But we need to get into grams because our density number is in grams. So 0.12 centigrams. Put grams on top. We want to cancel out centigrams. A gram is bigger, and there's 100 centigrams in a gram. So that's going to be 0.0012 grams. So this is a good problem because your teacher can test you over unit conversions at the same time as testing you over density. At the same time as testing you with rounding. So one of these density problems can see if you know how to do three different things. All right, so we have the mass. We know that volume from the problem is we are asked what is, we know that the density, is 8.92 grams per milliliter. So volume is mass 0.0012 grams over density 8.92 grams per milliliter. The grams will cancel and you're left with milliliters. So it's going to be 0.0012 divided by 8.92. All right, it gave in scientific notation, so we're just going to go ahead and do it that way. That'd be 1.34529, lots of numbers, times 10 to the minus 4. Well, what are we going to round to? Well, we have two significant figures here, three significant figures here, so we're going to round to two significant figures. That would be 1.3 times 10 to the minus 4 and that would be milliliters. All right, so there you go. If it would be 0.00013 if your calculator happened to give you the answer not in scientific notation. So unless it's a scientific notation problem specifically, I never really cared which one that whether I got a normal decimal method or scientific notation. All right, that'll do it for Chapter 1. So hope you remembered how to do all that. And if this video helped you out, please consider buying me a coffee on the Ko-fi link that I've put in the description box. You can scan this QR code. You can pay it has PayPal buttons on there or Venmo. The album of the day that I will link in the description box is the band Journey. So you may have heard that really famous song, Don't Stop Believin'. That song is not on this album. This is from the album Infinity. This is my favorite Journey album, and it's from 1978. I think it has some fantastic songs on it, so I'll link that in the description box. And feel free, as you're studying, to give that one a listen. All right, that'll do it. Talk to you next video.